Okay, the next part's about forces and orbits. We'll just have a quick look at that. And we said in class, well, if I take a student, we'll have this as Ethan, and you can pick which one you want in your head there. And if we had a piece of string and we attach that to a bucket of water, oh my god, that's the world's ropiest bucket. Even I can do better than that. That's a little bit better. With a bucket of water, if he swung it around his head fast enough, the water would stay in there. And the crucial part in this is, well, we've got two main forces. We have a centripetal force pulling inwards from the pull on his hand, and we have a centrifugal force pushing backwards. So if I just write that there, I've got a P and an F. Pulling towards him, we have centripetal, and pushing the water backwards. And again, equal and opposite. It's an interaction force pair, two forces between two objects that are equal in size and opposite in direction. Here is a centrifugal force pushing the water back towards the bucket. So now we've just got to label this orbit. And we know if we were to take this, let's use a different colour. That's absolutely pants, Mr. A-side. Let's get this sorted. And I'm going to go for that pretty green there. So if this is the planet here, we know that what's going to happen as it orbits is it's constantly changing direction. So it's got an ever-changing velocity because it's changing velocity. So it's accelerating all the time. And I find that lovely that a planet can go the same speed all the way around, but it's constantly accelerating because it's changing direction. And what we're going to see is all of these little arrows are mini little vector diagrams. So now let's look at labeling it. It says A, which part's the gravitational attraction? Well, clearly the star's pulling the planet inwards. That's A. B, what's the instantaneous velocity? Well, this is our idea of inertia. Objects that are moving want to keep moving in a straight line. So there's my straight line. This planet is orbiting and it's going that way. So the instantaneous velocity is B. The next part was the centripetal force. Centripetal pulls in, centrifugal pushes out. It's trying to trick you into putting it here. But the centripetal force is the same as gravity. And the last part, well, we've learned that we can do a vector diagram by, we've learned bum head. So don't ever put your arrows bum to bum. Don't ever put them head to head. Bum head. So I'm just going to redraw this. I'm going to get it roughly the right distance. So I've got, oh my God, that's disastrous. That's a little bit better. I've just drawn that one there. But now I'm going to take this force here and I'm going to draw it bum to head. And what we end up with is a resultant force that way. And this is what forces the orbit. So we can see how I get it. All these mini pulls are pulling it around in these directions. So this last one, I'll tidy all of this up. This last one now is the vector product, and D must be the orbital velocity. And I hope that helps with orbits.